test week, there's always people that just like, I don't know, I'm not going to take the test. It's not like it goes away. Let's see, 3, 4, 5. There's 5 people that haven't taken the test yet. 5 people, and even more that didn't take part 2. 1, 2, 3, 4, 5, 6, 7, 8, 9 people haven't finished the test. You've only taken part 1. So there's a lot of folks that grade is going to drop with all those zeros for not taking the test, which means you'll be here on asynchronous days, like next week when I get all the grading done. I got a lot to grade. I got like, I don't know, at least 70 or more, because all of my algebra classes were taking tests last week. So not only my Algebra 2 classes, but my Algebra 3 class. So that means I've got 3 classes to grade on last week's test. But if you're still missing that, get it done right away before you forget everything. But we're getting there. So, all right. Where's everybody at this morning? We've only got like half of us here. Well, we're over half. Okay, we're over half, but still missing several. Hope you had a lovely extended weekend. We supersized our weekend again. I like doing that. And we even had a Valentine's Day stuck in the weekend this time. So I hope that went well for you and had a lovely Saturday there. Little different at my house than usual, mainly because my wife was sick. She was sick like Thursday. She didn't even come to school. Friday, she did a half day and went home. Still wasn't feeling good on Saturday. Sunday, she felt a little better. Yesterday, she was up and around some, but even this morning, she's like, oh, I could have used another day at home. But she's in school today. But she had the flu or something very, very similar to the flu, and somehow I avoided it. So I'm tickled about that. Anytime you can avoid the flu, that's a good thing. We are going to hop into Buzz here. Oh, let me get it in the right screen and see what it holds. Since we are finished with the last unit there, since we took the test, we're ready to move on to something new this week. Yay! Let's see. I'll put this up on the screen so we can jump in there together and see what something new looks like. All right, looking at the grade screen. If you've taken the test, you probably don't have a grade. See, mine's got a grade there already, but I have 2 grades. I hadn't turned mine in until this morning. You should have at least the date you submitted the test, even if there's not a grade. You should have a grade for the multiple choice part, because the multiple choice part is automatically graded by Buzz. So you should have a grade for that. But part 2, you won't have a grade for, most likely, because not many of those were turned in early last week. I may have graded a few of them early last week, but most of them, if you turned them in, especially if you turned it in over the weekend, I haven't looked at any of that. So, but that's where you should be. You should be done with the exponential logarithmic functions and ready to start matrix operations. We're doing matrices. So this is broken up by weeks. This is week 25. Is it actually week 25? Did I do that right? It kind of varies from year to year. This is week 25. So here is the assignments we have on week 25. We have to do matrix dimensions, matrix elements, and representing linear systems with matrices. So that is what we're going to be looking at this morning. So with that, the first thing you're going to need to do, let me go back. I'm going to close this folder, open the matrices folder. And the first thing you'll see is starting the matrix unit. And it says if you're 0B, you click this link to make sure you're in my class on Khan Academy. So I want everyone to go to Khan Academy here, click on this link, and it'll tell you, hey, you're about to join Mr. Brock's class, unless you're already in there. Some of you are already signed in Khan Academy. It may already have you in there, but go to there, and there it says you're joining 0B Advanced Algebra 2 Brock. So I'll give you a moment to get into Buzz. We still got some people joining the class anyway, but we need to make sure everyone gets logged in, because we're going to spend the next 4 weeks doing some Khan Academy work. And when you get into Khan Academy, some of you may have joined by email. I sent an email last week from Khan Academy inviting you to join the class. But if you get to Khan Academy, hopefully it'll show you're in there, or it'll give you, or this link will say join. So click on that join button. Click on that join button if you haven't already. And make sure you are in Khan Academy. Get logged in. Probably already have assignments when you get in there, but we'll go through this together to show you how this works. So here. Yeah, we have 4 weeks. But we are going to be in week 25 this week. Okay, when we open week 25 in Buzz, we see 2 folders. First, we're going to do the introduction to matrices. So we have a video that we're going to look at here in class together. And then we have a lesson we're going to look in class. And then here are the 2 assignments. Those the 2 assignments have a different icon. But we're going to go through these videos, this video and lesson for this. And then we'll do the other folder, which it has just 1 lesson and assignment. So that's all we have this week. We're going to have 3 very short assignments. I'm going to show you how we're doing these. All right, I'm going to click on this intro to matrices. Now, this should take you to Khan Academy. When you click on this intro, well, it'll take you to this link, intro to matrices video. And when I click on this, this is where you can verify that you're logged in. So when you click on that, close those. It takes you to Khan Academy, and you will see up in the corner. Oh, well, right now, the full video. You won't see it with the video, but we'll get there in a minute. We're going to watch this together.
What I want to do in this video is explore the notion of a matrix outside of the context of a surprisingly good movie that involves Keanu Reeves, and it's actually the first of 3. I guess we could call the 3 movies combined the Matrices. And there is a relationship between the movie, which is about a virtual reality constructed by super smart computers, and the relation and the notion of what a matrix is when you study it in mathematics or when you study it in computer science. And the connection really is that matrices are used a lot when you are simulating things or when you're constructing things in computer science, especially in, frankly, computer graphics. So the super intelligent robots that made the matrix in the movie Matrix were probably using matrices in order to do it, if they actually did exist. Now, what is a matrix then? Well, that's a fairly simple answer. It's just a rectangular array of numbers. So, for example, this right over here, if I have 1, 0, -7, pi, 5, and, I don't know, 11. This is a matrix. This is a matrix where 1, 0, -7, pi, each of those are an entry in the matrix. This matrix right over here has 2 rows, and it has three columns. And because it has 2 rows and 3 columns, people will often say that this is a 2 by 3 matrix. Whenever they say it's a something by something matrix, they're telling you that it has 2 rows. So you see the 2 rows right over there, and they're telling you that it has 3 columns. You see the 3 columns right over there. I could give you other examples of a matrix. So I could have a 1 by 1 matrix. So I could have the matrix 1. This right over here is a 1 by 1 matrix. It has 1 row, 1 column. I could have a matrix like this, 3, 7, and 17. What is this? Well, this has 1 row. This is the 1 row we see here, and it has 3 columns. This is a 1 by 3 matrix. I could have a matrix, and I think you see where all of this is going. Figuring out the dimensions of a matrix are not too difficult. I could have a matrix that looks like this, where it's 3, 5, 0, 0, -1, -7. This is 7, -7. This right over here has 3 rows. So it's 3 rows, and it has two columns. So we would call this a 3 by 2. Oh, let me do that in that same color. We would call it a 3 by 2 matrix, 3 rows and 2 columns. So fair enough. You know that a matrix is just a rectangular array of numbers. You can say what its dimensions are. You know that each of these numbers that take one of these positions, we just call those entries. But what are matrices good for? I still might not be clear what the connection is between this and this right over here. And at the most fundamental level, these are just ways, this is just a compact representation of a bunch of numbers. It's a way of representing information. They become very valuable in computer graphics because these numbers could represent the color intensity at a certain point. They could represent whether an object is there at a certain point. And as we develop an algebra around matrices. And when we talk about developing an algebra around matrices, we're going to talk about operations that we're going to perform on matrices that we would normally perform with numbers. So we're going to learn how, or we're going to essentially define how to multiply matrices, how to add matrices, how to we'll learn about taking an inverse of a matrix. And by coming up with an algebra of how we manipulate these things, it'll become very useful in the future when you're trying to write a computer graphics program or you're trying to do an economic simulation or a probability simulation to say, oh, I have this matrix that represents where different particles are in space, or I have this matrix that represents the state of some type of a game. And I know the algebra of matrices, and I know ways of doing it very efficiently so that I can multiply a bunch of them, or I could run a simulation and I can actually come up with useful results. So that's all matrices are, but as you'll see through this, we can define operations on them. And then later on, when you take a linear algebra course in college, you'll learn a lot more of the depth of how they can be applied and what you can use them to represent.
That was our introduction to matrices. The main thing to get from that video is how do we define them? They have those square brackets on the side. And when we talk about a matrix, we're going to talk about how many rows and how many columns. So he was showing 2x3s and a 1x3 and a 1. That's the main thing to get from that starting out is when we look at a matrix, what's the size of the matrix? Because that's going to be important as we start working with matrices, knowing what size they are, especially if we want to add them together or multiply them or things like that. That becomes a key point in there. So that was our intro to matrices. So let me go back to Buzz here. So that was the first thing we find in the folder for this week is the intro to matrices video. So let's go back. And now here's the lesson that goes with it. The intro to matrices lesson. Again, it's a link. We click, close the other one. And when you get here, you can verify up in the corner that you're logged in. See, mine says, Mr. Brock, I'm logged in. So if you're not logged in at that point, you want to click on that button and make sure you get logged in. You can confirm right here when you get to a lesson or an assignment that you are logged in. So that's always good to know. All right, I'm gonna close this just so we can have this kind of full screen. So I'm going to turn on the chat because we're going to have some questions here that we'll answer. So a matrix is a rectangular arrangement of numbers into rows and columns. So this basically, we're going to review his video. We're going to go through this lesson, which basically talks about the same stuff, just to make sure we got it, make sure we understand what he was doing. So for example, matrix A, and a lot of times when we talk about a matrix, we'll name it with a letter. This is matrix A, this is matrix C, this is matrix F. We'll give them names that are just capital numbers. This matrix A is 2 rows, because we see left to right is a row, up and down is a column. Did it bother you that he misspelled columns in the video? Was that just me? Yeah, columns has an N on there. He didn't put the N. This is a 2x3. You do the rows first and then the columns. So the dimensions, so that's talking about the dimensions of this matrix, tells what size it is. The number of rows and the number of columns in that order. This is not a 3x2. This is a 2x3. It makes a difference. So since matrix A has 2 rows and 3 columns, we write its dimensions as 2x3. Pronounced 2x3. So in contrast, this would be a 3x2. Matrix B has 3 rows and 2 columns. So just remember, rows are first. So here's our class participation. I got the chat open. What dimensions is matrix D? All right, I got one out there. Nope, I've got competing answers now. I've got multiple people going both directions. It's either a 3x4 or a 4x3. Well, I like doing this right off so we'll get a chance to get together. Now remember, 3 rows, 2 columns is a 3x2. Rows are first. Rows are first. How many rows does this have? This has 4 rows. Columns. This is a 4x3. All right. A lot of people said 4x3. But we still had a few that we're not sure, but we're just getting started. All right. When we check on that, okay, it is correct. 4x3. Okay, what are the dimensions of matrix E? Right here. Then we'll do F in a minute here. What is E? We got to put F off the screen or we're not paying attention to F. How many rows and how many columns? All right, I see a lot of folks say it's a 2x4. Yeah, there are 2 rows and we do have 4 columns of numbers. So that is correct, 2x4. How about matrix F? Hmm. Oh, I'm not going to fool you now. You guys are getting the hang of this, aren't you? Guys are getting the hang of it. Rows first. Yes, there are 3 rows, but there is only one singular column there. So this is a 3x1. That is correct. Now let's talk about matrix elements. He didn't really talk about elements, but elements are the numbers that are in the matrix. There are 9 elements in here. And we can name them individually, not by saying 4, because look, there's 2 4s. So that wouldn't tell us which 4 you're talking about. If we say G2, 1, 2, 1, this is G. So we're looking 2, 1. 2 would be the second row and first column. That's what the 1 is. So 18 is the element that is in 2, 1 in the matrix G. So this goes in the same order, the row first and then the column. The row first. See, G21 is 18 because it's the row is 2. That's the first number. So we go to the second row. And then we look in the first column of the second row, and 18 is the number we're talking about. So let's check and see how we're doing here. Which element, which number is A 1, 3? Let's see if I can make this a little bigger on our screen just to help. Oh, that's much better. 1, 3 is which one of these numbers? All right, I see a lot of folks saying the same answer. So row 1, that would be the 2, -4, and 8. The third column would be the 8, and -5, and 2. So the number that is in the first row in the third column is the 8. Great job, guys. That is correct. How about this one? B. Here's the matrix, and we want B2, 1, which is the 2, 1 element in matrix B. Everyone's kind of agreeing here. What do you think? Everybody right? Or is there everybody seeing it wrong? 2, second row, 1, first column. You guys are nailed it. You guys are getting the hang of this pretty quick. 4.6. Yeah, 4.6 is the 2, 1 element. All right, matrix C is a 2x3. Oh, this is a good question. It's a 2x3, and C1, 2 is 6. So it wants to know which one of these. So I need to make this smaller so we can see them all. Which one of these could be that matrix? If 1, 2 is 6, okay, 1, 2, and it's a 2x3. So that's the important parts. I may need to make this even smaller to get all of it on there. Uh, there you go. I got all of them on there. It's a 2 by 3. 1, 2 is 6. Which one of these could it be? A, B, C, or D? All right. I see a lot of people saying C. So the first thing we can do is eliminate two choices by saying which ones are 2 by 3s. Right? Which ones are 2 by 3s? Well, A has 3 rows and 2 columns. So that's a 3 by 2. That does not work. It's not a 2 by 3. B is also a 3 by 2. So A and B have been eliminated. It cannot be A or B. If we go to C and D, those are both 2 by 3s. Both of them are 2 by 3s. Which one has the element 1, 2 as 6? There's the 6 and there's the 6. For D, it's the second row, the first column. This is 2, 1. This one is 1, 2. You guys nailed it. You guys got it. All right, check. That is correct. It is C. It is a 2 by 3, and 6 is in the 1, 2 position, first row, second column. All right, that is the end of that lesson. So if we go back to here, we have now looked at the video and the lesson. Here's our 2 assignments. Well, 2 of the 3, another one down here. Let me show you how these assignments work. So we go to the dimensions assignment. Take a screenshot of your score to put here in Buzz. If we scroll down, you can put a screenshot right here. But go to matrix dimensions. Now, if you're logged in, it will remember your score. So if you forget to turn it in Buzz with the screenshot, Khan Academy will remember. If you're not logged in, you have to redo it every time. So that's why you want to be logged in. Okay, matrix dimensions. So here is the assignment. There are 4 questions. 4 questions. When you click down in the corner, let's go. We have the first question. What are the dimensions of this matrix? All right, so what is that? I'm doing this assignment now. What are the dimensions? I can make that a little bigger. I'm seeing some 2 by 3s. Remember, we're going to look at the rows first. So there are 2 rows. There are 3. Go away. 3 columns. Okay, that is a 2 by 3. And you hit check down here in the corner. Oh, good work. Keep going. And it made a little noise that you didn't hear. But next question. What are the dimensions of this matrix? Well, it's all 2s and 5s matrices. If you get one wrong, it'll tell you how to do it. And it also has videos down here. Here's a video in the article that we just looked at, that if you're confused, you can go to one of these and look at the lesson again. All right, so we're saying 2 by 5. Yes, not 3, 5. It is 2 rows. It is 5 columns. Check. Good work. You got it. Next question. Oh, what are the dimensions of this matrix? We got a 1 and a 0 and a 3 are the elements. 1, 2, 3 rows. 3 rows. 1 column. Nice going. Question number 4. Our last matrix. What are the dimensions of this matrix? Let's see. How many rows do we have? We have 1, 2, 3. We do have 3 rows. Columns, 2. All right, so this is what happens. Boom, show summary. 4 out of 4. Oh, they give us a little some confetti. This is where I want to take a screenshot. Right, so I take a screenshot of this screen. Let's see if mine's working. Where's mine? Here's my little snipping tool I do. So when I take a screenshot of this screen, it shows on the screenshot my name, Oh, there's my name and how many I got right. So I'm going to go back to Buzz. I'm going to go down here and I'm going to paste that screenshot. And I'm going to submit my work. Okay, I've turned that assignment in. Now, if I forgot and I go back here, it will remember, oh, look, you got 100%. I can go back and screenshot this to show I got 100% if I need to, if I forgot. So like I say, if I go back to it, forgot to screenshot it, I can go back here. It wants me to start over, but it shows that I've already done it over here. Now, here's the key, though. Most of the time, let me say 98% of the time, because I can't say everybody does this. This is the unit that brings your grade up if you're struggling in this class, because if I didn't get 4 out of 4 and I only got 50%, 2 out of 4, I don't want to get a 50%. That's bringing my grade down. That's not even passing. I can close Khan Academy, go back to Buzz, click on the link again. It'll take me back to Khan Academy, and I can do it over. I'm not going to take a screenshot when I got 2 out of 4. I'm not going to turn that in. I only got 2 out of 4. That wasn't good. I'm not going to, I'm going to go back and redo it and get 4 out of 4. Maybe I need to go look at the lesson again. If I'm only getting 2 out of 4 because I don't understand. Okay, let me go look at the lesson. The lesson didn't take long. Okay. Oh, I got it. That's what I forgot. Okay, I got it now. So now when I do it, now I can get 4 out of 4. That's the one I'm going to turn in. And that's what most students do. And so this is a unit that helps bring your grade up, because you can wait and turn it in when you get 100%. 100%, 100%, 100%. This week, you should be able to get 3 100% because we've got 3 assignments on these matrices. So turn in the grade you want. That's the nice thing. 4 questions. It's quick. It's very short. We did that very quickly. And you can do that as many times as you want to. You can redo it until you understand it and get it right. Okay. So we've done matrix dimensions. Let's go back here now. Now there's a matrix elements assignment. So the next assignment, same thing, screenshot, turn it in here, matrix elements. Okay. Ready to practice. Show us what you can do. Let's go. What is the element that is a 1, 3? It's still large yet, but I can make it bigger. Which is the 1, 3 element here? Oh, there's going to be some good grades on this unit. You guys are understanding wonderfully. 1, 3, 1, 3. So the first row. So it has to be one of these because it's first row. And it's the third column. 1, 2, 3. Yes, it has to be the 13th. Turn that in. Great work. Excuse me. Next question. Oh, big matrix. 5, 1. Which one is 5, 1? There's a bunch to choose from there, folks. And only one of them is the 5, 1 element. Yes, so 1, 2, 3, 4, 5th row. It's one of these bottom row, and it's the first column. So yes, great job, everybody. It's the 2. Nice work. Now we have a 3 by 3 matrix, and it wants to know the 2, 1 element. The 2, 1 of this 3 by 3. So second row, first element. There we go. Great work. You got it. Onward. 4 and 4. See, it keeps track at the bottom too. So if you can't remember if you missed one, check. Those are all correct. 5, 3, which is the element at 5, 3, and this 1, 2, 3, 4, 5. 5 by 4. This is a 5 by 4 matrix. But we want to know 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. It is number 1. Check. Show summary. All right, ready for that confetti. There's a screenshot. Go back in. Yep, there's my screenshot. I'm going to turn it in right here. Submit my work. Okay, I am done with the intro to matrices folder. The other assignment we have is still in the week 25 folder. Remember, you're doing everything in the week 25 folder. Representing linear systems of equations with augmented matrices. Now that we know how to identify matrices and how to identify elements, let's start working with them a little bit. Representing linear systems with matrices. Okay, close that. So the first thing it'll do every time, I'll see if I can leave it this large. I may need to make it probably one notch smaller. Is it reviews at the very beginning of the lesson? A matrix is a rectangular arrangement of numbers into rows and columns. See, this is a review. We already know this. We already know that this is a 2x3 matrix. A systems of equations. All right, remember systems of equations, 2x plus 5y equals 10, 3x plus 4y equals 24. We actually looked at systems of equations back early in the year. But we could take these and turn them into a matrix, these two equations. Look how we do this. We have a 2x in this equation and a 3x in this equation. So we can take the first column and make it the coefficients of the x. So this is the x column, and it's 2 and 3, representing the 2 that's there and the 3 that's there. Now look at the second column. The second column is the y column. The first equation has 5y. Second equation has 4y. So we pull out the 5 and the 4 and put it in the second column, the y column. This last column is the constants, just the numbers that the equations are equal to, 10 and 24. So if we look at it, the first row represents the first equation. Equation 1 is 2x plus 5y equals 10, or in our matrix, 2, 5, and 10. We drop the variables and just keep the coefficients. The second equation, we have 3, 4, 24, which represents 3x plus 4y equals 24. All right, questions on that? That kind of makes sense so far? All right, just looking at it. This is called an augmented matrix. In an augmented matrix, each row represents an equation, and each column represents a variable or the constant. This is the x column, the y column, the constants. So in this way, we can see that augmented matrices are a shorthand, it's a shortcut way to write systems of equation. The organization of the numbers in the matrix means we don't have to write x, y, and equals, because we know that, oh, well, the x's are just this one and the y's are just this one. Okay, so they're going to give us two choices, A or B. Which one of these represents this system of equations? A or B? All right. The first row is the same in both of them, so that doesn't tell us anything. 2, 3, 8, 2, 3, 8. The equation is 2, 3, 8. So either one of them could be looking at the first row. But when we look at the second row, 2, 5, 2, or 5, 2, 2, looking at the equation, it's 5x plus 2y equals 2. The x column should have a 2 and a 5. This one has a 2 and a 2. This one has a 2 and a 5. It should be B. They've taken the 5 and 2 and put them in the wrong space. They've reversed the x and y. X's have to be together. Y's have to be together. Check. Perfect. All right. This one we get to write. So what is the first row? What numbers am I going to put in the first row of our matrix? Give me all three numbers. Give me all three. What's the first thing? In order. All right. Truman's going to nail this assignment here. Job. All right. Well, a lot of you guys, you got this figured out. 7, 4, 3. 7 is the X column. 4 is the Y column. X, Y. And then 3 is the constant at the end. So the second row would be then what? In order, 6, because this is the X's. If 7 was the X, 6 is the X in the other equation. 4 was the Y, so we got to put the 3 in this one. 3 and 5 is the last column. Ah, wonderful. All right, let's take a look at another example. We got the basics down. This is a little more complicated, a little bit, but I think you guys got a good feel of this. So let's look at this system. 3x minus 2y equals 4. X plus 5z, oh, we got another variable, equals negative 3. And negative 4x minus y plus 3z equals 0. So we want to write this as a system of equations. So if we go down, we can modify it to make it easier. Because look, this has an x, this first one has an x and a y, but it doesn't have a z. The second one has an x and a z and doesn't have a y. The last one has an x, y, and z. So if we go and say, well, if we rewrite these to where they all have all three, 3x minus 2y plus 0 z's. Like there is a z in the first equation, but it's 0. That's why we don't see it. If there's 0 z's, we didn't write it. So if we go back and remember that if it's missing, there's no y in the second equation. If we add 1, it's a 0. There's no y's. So when we turn it into a matrix, we have to remember to put those zeros in. The first equation is 3x minus 2y equals 4. That means there would be no z's. We'd have to put a 0 into that column, in the z column. The second equation was what? 1x plus 5z equals negative 3. There's 1x, there's 5z's, but there are no y's. So we would put a 0 into that position for that negative 3. And then the last one had all three variables, the negative 4x, the negative 1y, the 3z. So we could put all those and it equaled 0. So every column corresponds to what the x is, and all of those had an x. What the y's are, filling in the 0 if it's missing a y variable, and then the z, and then the constant. So we're still consistent on the columns. It's still an x column, a y column, a z column, and a constant. So be sure the variables appear in the same order in each equation. That's the big thing to keep track of. We're not going to switch the order. So here's another one of these. Which matrix represents this systems of equations right here? This system of equations. 3w minus 2x plus y plus 5z equals 10. Woo, so we've got 4 variables and a constant. W plus 2y minus 4z equals 5. All right, so it's going to be A or B. Look at it carefully. Again, the first row is the same. 3, negative 2, 1, 5, 10. So that doesn't tell you anything. It's the second row that's different. So is it A or B? A. We got a lot of A's going on. Nobody's going to buy the B. So let's see what we're looking at then. Everyone believes it's A. So in the first equation, we had 3 as the W column. So this is the W column. So if it's A, that means we have 1 W in the other equation. And we do. There is a W. The second column was negative 2x. So this is the X column. And we're saying there are 0 X's in the second equation. W, 2y, negative 4z. I believe you're right. Absolutely. We were missing an X. So in the X column, we have to make sure we have a 0, which would be the second column. Okay. We have another one that we have to write. We have negative a plus b minus 2c equals 12. We have 3a plus b equals negative 8. So give me the first row, all the first 4 numbers that go in the first row. I'll make it a little bit trickier. Not hard for you guys. I know you guys can nail this. I'm just saying it's just not as simple as the other one. I'm seeing -1 and then a +1 and a -2. And is it a positive or -12? I'm seeing both. Some people have a -12. Some people have +12. Right, that's a 50-50 split. I've got half the people saying it's a -12. Now everyone's agreeing to this, so we can put this -1, +1, -2. But is this going to be a +12 or a -12? Some of you guys have fallen out. Are you getting confused? We had a lot more people participating earlier. Now it's only like 5 of you doing this. If you're getting confused, we can slow down and look at this again. Make sure you understand it. Truman's going to break our tie. He says -12. All right, you guys are saying -12. I'm going to put it in there. What about the second row? Second row is a little different. It's got 3a plus b equals -8. What numbers are we putting in there? 3, 1, and -8. But I have 4 columns. I have 4 columns that I have to fill up. So this is the A column because we had -1. So that is a 3. This is the B column, which I had 1B, and there's also 1B here. This is the C column. Uh, hmm. Yep, no C's. And -8. All right, let's check. Oh, there's something wrong. Yeah, there's not a negative in front of that 12, guys. That's just a 12. Don't put a negative in. That's a +12. So we had people saying both positive and negative. All you have to do is match exactly. If the sign is negative, this is -1. If the sign's positive, this is +1. Over here equals 12's positive, 8's negative. 12's positive, 8's negative. Oh, a challenge problem. All right. We're gonna make it a little harder on us. Okay, which A or B, which one of those represents this one? This is a challenge problem. They're making it hard for us here. A or B. This is the one that counts right here. This is for all the marbles. If you like marbles. A or B, which one of those? So this is a 1, 2, 3 by 4, 3 by 4 matrix. And which one of these represents this 3 by 4 matrix? Well, let me look at it carefully. The first row is different. The first equation is different, not the first row. First equation is different. The second one, 4x plus y plus it. That's the same. So the only thing that's different in these two answers is the first equation. The first equation. It's either -3x minus 5y equals 8 or -3y minus 5z equals 8. All right. I had a couple of folks say A. I had more folks say B. So looking at it, the 0 is in which column? The 4 and the 5. If we look here, the 4 and the 5 are both x's. So this is saying there's a 0 in the x column for the first equation, which means we would not have -3x because we should have a 0 in the x column. So this one has got to be it. There is no x. That is correct. All right, another challenge problem. Oh, this one's got 4 of them. I got to make it smaller so we can see them all. Which matrix represents this system? This is another challenge problem, so we'll see. Oh, gosh, what did I do? There it is. 3x plus 2 equals 12y. Oh, this is good. This is a good one. All right, put your choices, A, B, C, or D. You may be looking at it going, okay, I'm confused, Mr. Brock. I see all this up here, but these equations are very different. All right, I'm seeing A's and C's as possibilities. Okay, A's and C's. Let's dig into this just a little bit more. If we're going to compare these, is my light on? My light's not on. There it is. Okay. If we're going to compare these, let me turn this a little bit. Okay. This is 8y, negative 8y. In order to turn these into a matrix, we got to have the x's in the same column, the y's in the same column, and the constants in the same column. But these are written very differently. So we need to reorder these to where they're the same, where they're in order, x, y, constant. So let's take this first one, 3x plus 2 equals 12y. And we need to rearrange that. We need the y to be over here and the constant to be over there. So how do we do that? Well, subtract 2 from both sides, the same way we always do this in algebra. We want to move something to the other side. And we need to move the y over here, so we subtract 12y from both sides. The x's and y's have to go separately, so this is a 3x minus 12y equals negative 2. So I'm going to rewrite that over here. 3x minus 12y equals negative 2. Okay, so this is in order now. X, y, constant. So I'll put it over here. This one, negative 8y equals 2x plus 15. The 15 is already on the right side. The y is already on the left side. We just need to move the x. And we want to put these in order. The x goes before the y. Negative 2x minus 8y equals 15. Negative 2x minus 8y equals 15. Now we've got the two equations in order that we can convert to a matrix. So the matrix would be 3, negative 12, negative 2, negative 2, negative 8, 15. This is the matrix we're looking for because we have to rearrange those first. Let's see if we have one that matches that. 3, negative 12, negative 2. 3, negative 12, negative 2. It is C. C matches that. C has the same numbers in the same order, which we had to rearrange the equations. So don't be afraid to pull out pencil and paper and rearrange things if you got something like this that gets real confusing just trying to eyeball it. Check. It is C. The problem with A is it just takes the numbers as they are, 3, 2, 12. But if we rearrange things to put them properly, the 12 and the 2 are actually negative because we've got to move them to the other side of the equation. All right, that's the end. There's questions down there. Let's close that. We've looked at the lesson for representing linear systems, so let's do the assignment for that. Screenshot down here at the bottom. Represent linear systems. All right, here's our assignment. And close this little tab on the side just to give us more room to see it. Ready to practice? Yes, we are. Which of the following matrices represents this system? A, B, C, or D? Let's see. These are in order. X, Y, T. Well, they're putting T last. I mean, it's not alphabetical order, but they're in the same order is what we have to look at. X, Y, Z, T, X, Y, T. So the first thing we notice is the first equation is missing the Z variable. So the X, Y, Z would be the third variable. So the third variable up here would be a 0. And it's negative 11 and 18. Look, the first one up here is 18 and negative 11. That's not right. The last one is negative 2 and 18. This is backwards. There's something wrong with this. So it has to be B or C. B or C. 340 negative, 340 negative 2, negative 11, 8, negative 9. So it looks like the second row is the same on both of those. This one has a 1 in there for the z. Well, there's no z in the first one, so it has to be b. All right, Aiden was on top of that. Check. Correct. Okay, second one. Oh, now we have to write this one. This shouldn't be hard. This is a simple one. We got an x, a y, and a constant on both equations. So 3x's, 1y, 1 constant, 2x's, negative 2y, 0 constant. That one's quick. Yes, that's correct. Oh, here we go. Here's another one. Which of the following represents the system? We got an x, z, and a t, x, y, z, and t. So they're in the same order. It's just the first equation does not have a y. So where would that 0 go? 10 and 4. These have negative 4 and negative 10. Like we have to rearrange those. So C and D are out because that last column we know is wrong. And the last columns are different here. This is the only one that has a 10, 4. 10 and 4. And it has the 0 for the y right there. That's what we're looking for. There's an x and a z. It says an x, y, and z. So that missing y should be right there in the second column. Yay. And another one that we write. Oh, they gave us another simple one. It just has x's and y's and a constant. 4, 4, negative 8, 9, 1, 6. There it is. Show our summary. Their little confetti. Screenshot. There it is. Submit my work. And that's all we have for this week. That is all of folder 25. We have turned something in. If we go look at our grade screen, it'll show that I've submitted something for all those assignments. Then I'll have to go in and put the grade in for it. I'll go look at it and see that you got 4 out of 4 and make 100% on that assignment. So, all right, guys, this is what we're going to be doing for the next 4 weeks. We're going to be looking at matrices through the Khan Academy. Make sure you're logged in, because if you forget to log in and then you don't take a screenshot, when you go back, it'll be gone. You'll have to do the assignment over again, which isn't bad. It's 4 questions. But use this wisely. Don't take a screenshot if you get 1 out of 4. Redo it. Close the window, reopen the window. It'll let you do it all again. So you can get the grade you want every assignment on this Khan Academy work. So, all right, guys, you got enough time to probably get this done before your next class. So I'll give you the rest of the period to work. That's all I had to present today. So the rest of the period's yours. You can hang around here if you want, or you can go off and work on it on your own. But I'm here if you have questions.